Colligative properties of solutions are properties that depend on the concentration of solid molecules or ions, but not upon the identity of the solute. There are four types of colligative properties. The first one, vapor pressure depression. The second one, boiling point elevation. The third one, freezing point depression. And last but not least, osmotic pressure.
The vapor pressure of a solvent decreases when we add a non-volatile solute, and this depends on two very important factors, which are the decrease of the number of the solvent molecules and the appearance of forces between the molecules of the solute and the solvents, hindering their passage to the steam. The boiling temperature of a liquid is which its vapor pressure is equal to the atmospheric one, and any decrease in the vapor pressure will produce an increase in the boiling point. The elevation of the boiling temperature is proportional to the mole fraction of the solute.
For a solution with a liquid like a solvent, the temperature at which it freezes to solid is slightly lower than the freezing point. This phenomenon is known like freezing point depression. The lowering of the freezing point is given by Kf times m, where Kf is the constant which depends on the specific solvent, and m the molality of the molecules or ions solute. Osmosis is the movement of water from an area of low concentration of solute to an area of higher concentration of solute. Osmotic pressure is given by the equation of I times m times r times t, where I is the Van Hoff factor, m the molarity, r the constant, which values 0.08206, and t the temperature in Kelvin.
There were three objectives in this practice. The first one was to analyze the theoretical knowledge acquired at colligative properties. The second one was to determine the boiling point and melting point of a pure compound and its dissolution. And the last one was to increase the temperature of a solution by 2 Celsius degrees with the help of a solute. For the first experiment, we wanted to increase the temperature by 2 Celsius degrees, but we didn't have the weight of the substance. We only got for data the Van Hoff factor of 1.8 and the volume of 10 milliliters. So we needed to clear these three formulas to get the weight. For the second experiment, we wanted to know the Van Hoff factor, but we only got the temperatures. So from these two formulas, we clear 4I.
We did the first experiment twice because the calculations were made with 20 milliliters of water instead of 10 milliliters. And for the second experiment, we did it 3 times because the solution was not well made. Therefore, we didn't know if the molarity was higher or lower, and that's the reason why we could not get the expected results.
In this practice, we could observe the accuracy to measure correctly the compounds that we use in our solutions. It's a really important factor that directly affects the results of our experiment, as well as taking care of handling the materials, and we prevented that our body temperature cannot interfere in the results of our experiment.
When we separate a solution, the colligative properties of this, such as the freezing point, the boiling point, and the vapor pressure, change respect the pure solvent. Inside the laboratory, we pass from the theoretical to the practical, and we saw the colligative properties of a compound and all the variabilities we have to control for a successful experiment.